Hi, my name is David, and I try to play guitar. I'm not very good, as you can tell. One day, I saw a video of blues great Joe Bonamassa getting very technical about his guitar amplifiers. For a guitar player, that guy really knows his stuff about amps. He inspired me to learn more. But to really understand guitar amps, you need to take them apart and put them back together. I watched hundreds of videos. I read all kinds of books. From Craigslist and eBay, I bought a used soldering iron, some old voltmeters, an ancient oscilloscope, and other test gear. Eventually, I built an entire electronics lab. Now, I guess I'm sort of an amp mechanic. I fix other electronics too, and this is my journey. I figured I'd share so others can learn too. I hope you like it, and just as a disclaimer, be sure to consult an expert before working with electricity. Hi, Dave the Amp Mechanic coming to you from my amp lab in Boston, Massachusetts. Right now, it's January of 2020. We're in the middle of the winter up here in Boston. It's cold outside, and I just got done fixing a Marshall 3310 mini stack. You can look for the video on that on my channel. I'm not sure if it's uploaded just yet. You might catch this video before I've uploaded that one, but it will be up there soon if it's not already up there. And I went to start stringing together all the different video segments into one video when I realized that my hard drive on my computer was full. What was it full of? Well, it was full of other video segments that I've recorded for other things that I haven't turned into videos yet. So I decided now's the time to really get that done and get that hard drive cleaned off so that I can get all my videos out the door and start moving on to other projects. One of those videos was a video I shot where I took the skills that I've been learning by fixing amplifiers and radios and other things like that, my electronic skills, and applying them to a project that was really an important project for my house. And that project had to do with the sprinkler system. The sprinkler system at our house had a problem where, and this was in the middle of the summer of 2018, so that gives you some idea of my backlog on videos, but the sprinkler system had a problem where one of the zones just kept running. Like even if you turn the sprinkler system off, it just kept running. And I'm not a real expert on sprinklers, but I thought, well, wait a minute, there's a little bit of an electrical component to the way sprinklers work. And so maybe with some of the skills that I've picked up and my digital multimeter, I might be able to figure out what the problem was. So this video is a video not about repairing amps in the amp lab, but rather repairing the sprinkler system for my house. So I know it's not an amp repair, sorry about that, but kick back and if you happen to have sprinklers and you may need to repair them at some point, this video may come in handy. And oh, by the way, I don't do these videos to make money. If you look at the number of subscribers I have, number of views I get, there's no way I can make money. It's a losing proposition, and I won't make money anytime in my lifetime. I do these for fun of it, for the fun of it. What you can do though is you can subscribe and you can like, because when you do that, what it does is it sends a little bit of a signal to Google and YouTube. Hey, this video is worthwhile. Maybe show it in search results to other people who are looking for similar content. So I just want to make sure that I'm helping as many people as possible, paying it forward, because I've learned so much, not only from YouTube, but from other people who are knowledgeable in the area of electronics. Anyway, that's all I have to say. Let's get to fixing my sprinkler system. Okay, so here's the control station for our sprinklers. And if you kind of zoom in right here, you can see that it's showing that there's one day, we're on day number 1 right here. And what that means is that today's the day it should be sprinkling. I have it set to sprinkle every other day, which you can set this down here. Like this is every 2 days or every other day, every 3 days, every 5 days, or you can set it to a custom amount of time. We're right in the middle of the summer when it's very hot and the lawn can burn up, so I'm going every other day. And right now the system is off, and here's what it looks like when it's on. So I come over here to this button here and I just start the system manually, and that starts, now it's what it's telling us, it's on zone 1, and it's going to go for 30 minutes. If I click this button here, it goes to zone 2 for 35 minutes, zone 3 for 50 minutes. That's the zone that's right in the sun all day long. That's why we give it more water. You can see zone 3. Click it one more time. Whoops. Zone 4, 50 minutes. Also, that one's in the sun a lot. And then when you hit it again, it'll go off because I only have 4 zones. Boom, it's off. Okay, so that's how it works. The problem is when it's off, the sprinkler just keeps running in zone 2, right? So that's the problem. Now, in order to figure out, to make sure it's wired correctly, and also I figured I'd, use my electronics lab, my amp lab skills to help me out here. You can tear this panel off, and I didn't realize you could do that. So here, if you take this panel off, you get some idea of how these sprinkler controls work. So this wire right here runs all the way out to what's called the manifold, and I'll show you the manifold, of course. This wire right here runs out to the sprinkler manifold, and you can kind of see right here that it's numbered 1, 2, 3, 4, and what that is that these are each of the valves for each of the zones. So if you go out to the manifold, we'll see that the wire that's red is going to the valve for zone 1. The wire that's green goes to the valve for zone 2, yellow for 3, and blue for 4. And white, as you can see, says com or common. That's the ground, right? So at the manifold, we'll look at this wiring, and you'll see how easy it is because these wires are just connected up to the solenoids for each of the valves. So we'll take a look at that. But it's a relatively simple system because basically all it's doing is saying is, like, if I click this and I go and it's on zone 1, basically what it's doing is it's on this red wire, it just energized this red wire with 24 volts. And those 24 volts are going out to the solenoid and activating the electromagnet in the solenoid in a way that it opens the valve underneath it. And I'll show you how that happens. And so the whole control is pretty straightforward. As it goes through each zone, it just energizes each line with 24 volts. And that's common, when you think about 24 volts, pretty much everything in your house that has relays or solenoids or anything like that all runs on 24 volts. That's common, the heating system, the thermostats, etc. And so it just energizes these. It takes turns, zone 1, zone 2, zone 3, zone 4, and then as soon as it's unenergized, the electromagnet out at the solenoid is unenergized and the valve closes. It falls into place, and that's it. Now this other wire here is just simply going to the power supply for the whole system. So as you can imagine, if this is running on 24 volts, if we come way down here to where that's plugged in, all this is one of those wall warts, 120 volt wall wart that converts it in. It's a transformer that steps it down to 24 volts. Right, and so you just basically have the same things you see on any transformer. It's a 3-wire system, and the green wire here is grounding the chassis. And look at that, you can even see some capacitors in there, right there. But these are those disc capacitors that almost never go bad. So yeah, that's all you really need to know about the control, the sprinkler control. Okay, so here's where the sprinkler system is, and what I'm showing you right now is basically just where the hand valve that controls the supply to the entire sprinkler system is. And as you can see right now, It's like in the 9 o'clock position, like if you come to the side here, which is the off position. These hand valves, the way they work is when they're vertical with the pipe that they're mounted to, that means the valve is open, and when they're turned to the 9 or 3 o'clock position, that means it's closed. And basically, that supply goes down that black pipe that's right there next to our fence, and then it drops into this area here in the ground, which is where the sprinkler valves are. And the sprinkler valves are organized into what's called a manifold. It's not terribly different from the exhaust manifold in your car, in that you have one entry point, and in my case, because there are 4 zones, 4 exit points, each of them controlled by a sprinkler valve with a solenoid mounted to the top of it, each solenoid having one of those electromagnets in it. The next thing we need to do is pop the cover off of this little box here to reveal the manifold, and then we'll get down to business and figure out what the problem is, and we'll get it solved. Okay, so pop the top off. You just lift this up, and you can hear that there's a little bit of buzzing in there, and that's because down at the panel, I've manually set zone 2 to be activated in a way that I can test the circuitry and make sure that the circuitry is working. So I'm just going to get in here. Now, as you can see, these are the valves, these gray pieces here. They're called the valve housings. And these are called jar tub valves because this housing with these little grips on it screw off like a jar top. And these things are the solenoids and they screw into the jar tops. Now remember, if we go back to the panel, we had a variety of different colored wires, and this black wire here is what goes all the way back to the panel, and then these colored wires come out of it, including one white wire. There's the white wire right there, and as you can see, it's joined with a wire nut to one side, one wire from each one of my valves. Now, when I first opened this up, these things were buried 15 years in the ground, and I don't think that's the way the installer did it. I think what happened was over the years you get bugs and worms and all kinds of things, and they make dirt. And eventually this thing started filling in and getting buried. So I had to excavate this whole area by hand and get it all cleaned up, because if we end up having to open up any one of these valve housings, you don't want any dirt getting in there because it will corrupt the operation of the mechanism. But I don't know if it's in view or not of the camera, but like here's valve 4, and valve 4 is the one is buried completely. I haven't excavated that yet. So right now there's no water flowing through this because I have the hand valve at the supply to the entire manifold in the 9 o'clock position, which means it's off. But the first thing I want to do is, so this is, by the way, this is zone 1, this is zone 2, the problematic zone, and I can even put my finger on this and I can feel it vibrating, which means that the solenoid is operational in there, or something's going on, we don't know what. This is zone 3 and zone 4 over here. This is my problem zone. That's why I got in there and excavated it, and you can see my fingernails are still, I got dirt under my fingernails from doing that. So it's a messy job to excavate around these. And then what I did was I came back with a hose and I rinsed this hole off because there was dirt everywhere. And again, like I said, once you start opening these things up, if you have to, you want to avoid getting dirt into anything, because that can hurt your assembly in some way. It'll corrupt it, keep it from working. So the first thing I'm going to do here is let's just this wiring is kind of a mess, and just like with amplifiers, what we want to do is, you know, if you open up an amplifier, you want to make sure that that when you put it back together, you put it back together and it's nice and clean. So what I'm going to do is I'm going to actually take the wiring apart first, and in a way that we can put it back together. It'll be very neat and much easier to work with. And so we'll do that. But before I do that, let's just do a check with the voltmeter to make sure we're getting our voltage. It sounds like we are. I just took that wire nut off. And oh, one thing that's interesting about these wire nuts, these are special wire nuts. They're packed with like a grease. And the reason they're packed with that grease is because it helps waterproof the contacts here in a way that if it rains or they get wet, it doesn't. It basically keeps the contacts from corroding in a way that would prevent the sprinkler system from working. So just remember, when you're putting it back together, use these wire nuts that have some grease in them. So I'm going to set this aside, and I'm going to basically just disconnect. Well, I can actually leave that connected for now, but the wire that we're interested in working with is this one here. So here's the ground wire going to the common for solenoid number 2. That's this wire, and there's no, it's not like a polarized capacitor. You know, you can do either side. It doesn't matter. One can go to ground. One can go to your hot lead. This is the hot lead. So I don't know if you can hear the humming, but I'm going to take this guy off, this other wire nut, and more than likely, when I disconnect this, the humming's going to stop. Boom. Stopped. Alright. So, alright. So now that we have that off, real quick, let's go ahead and just check with our voltage meter. Let's check what we're getting in the way of voltage here. So I'm going to clip I've got my voltmeter here, and I'm going to clip one end to the green, and I'm going to set ourselves to DC volts. And let's see what we get. I don't know if you can see that. I'm sorry. We're at AC, not DC volts. And if you can look, you can see we're getting 27 volts on this connection. So that basically tells you that we don't have a problem. We don't have an electrical problem, at least coming from the box in the basement, the sprinkler control. That's working fine. Okay? So all I'm doing is I'm touching the common or ground wire with the common lead from the voltmeter, and then over here this is connected to the hot lead. Alright, so what do we do next? The next thing we're going to do, put the voltmeter away. And by the way, I used my Klein voltmeter, which I don't use for my amps because it's not rated properly, but for this basic type of home use, any voltmeter will work. And so the next thing we're going to do is we're going to take the solenoid off and make sure that that solenoid is operational. This is really easy. All you do is you unscrew it like that. You just turn it counterclockwise and it'll screw right off the top. Now some water is going to come out. See that water coming out right there? That's okay, because all that's happening there is the sprinkler system is draining itself. And so some water is going to drain out of the sprinkler system. That's fine. In fact, it's cleaning off the sprinkler some. So now the trick is, let's go ahead and let's see if the solenoid works. Now remember, we still got one side connected to ground, so all I have to do is touch these two things together right here, and the electromagnet, which is inside here, should pull this guy in. You see, that's spring-loaded. I don't know if you can see that, but that's the valve, and it's spring-loaded. That's a solenoid, and when the electric magnet, which is on this end, is magnetized, it pulls that valve in. And so to magnetize it, you just apply 24 volts or whatever the voltage is, 27, and you should see it click. So let's see what, there's a mosquito here. Let's see what happens. So that works. See, every time I touch it, it pulls it in. So that's good. Okay, that means our solenoid is good. So now we just have to figure out, well, what's the other problem here? And the next problem would be to test if maybe the hand valve is broken in some way. And what I mean by that is, if you look closely at this jar top valve, it's got this guy right here, this little tab. And the way that tab works is, if you look very closely, and I'll try to get a close-up with the camera, it says on this direction, the counterclockwise direction, off this way. Which means that what you can do is, let's say something's not working and you need to run a sprinkler zone, you can just reach in here and you can turn this knob that way, and it will actually activate the zone for you by hand, right? And the way you can turn it all the way counterclockwise, and then when you're done, you just turn it clockwise like that, and it's off. Now, I've already gone to the trouble of diagnosing and saying, okay, well, what happens if is that valve the problem? Like, in other words, is something wrong with that in a way that just lets the zone run continuously as though it was always in the on position? And that's not the case. So the next thing we need to do is say, okay, well, what else could be the problem? So the way these work is, this little thing just slides off like that, because all it's just gripping this ring here, right? So you can just put that to the side, and then, whoop, we're going to use this to loosen that up. There's another part in here. This is almost like when you're changing an oil filter. You just put this thing on it and you turn that thing, and now it's loose enough for me to loosen it by hand. This part comes out here, okay? And the way this works is, if you can see that there's ridges here, this thing just slides over that and it turns it this way, right? Okay, so I just unscrewed it and took it out. There's the threads that go into the jar top. And what I did to eliminate this mechanism, because I don't know if you can see very closely right here, there's a little O-ring here, and I thought maybe that's the problem. So I thought, okay, I'll eliminate that O-ring as potential problem. And what I did was, I took the whole mechanism, this piece of the mechanism, out of one of the zone 3's valve housing and moved it over to zone 2, and nothing changed. In other words, by switching them out and putting the one that was from zone 2 into zone 3 still worked perfectly. So that told me that this mechanism, and this one was originally from zone 3, this mechanism that was originally in the zone 2 housing, or the one that was in the zone 2 housing, was working fine, because it works fine in zone 3. I can literally turn on zone 3 by hand and turn it off by hand. So this piece, this part, is not the problem. So what's left? We know the solenoid's not the problem. We know this piece here, the solenoid's not the problem. That works fine. We know this is not the problem. That works fine. What could be the problem? Well, what's left is what's inside of this housing, this jar top housing. And what's inside there is called the diaphragm. So when we look these up, these are called the Irritrol. These are made by a company called Irritrol, IRROTROL, and this is the 2400T valve. And inside there's a diaphragm. And so the next thing we need to do is we need to disassemble this particular valve housing, and we have to take the diaphragm out and replace the diaphragm. Now, one of the great things about these jar top housings is that they're built that way so that you can just grab this and take it off. And the reason that's so great is because you don't want to have to disassemble the whole manifold and replace the valve housing. The valve housings don't generally go too bad, right? It's the diaphragm inside. And so if you look here, you know, like this whole thing, you can't even move this. It's in there pretty solid. So to kind of get in there in a way that you would unscrew the valve housing from the manifold and then separate it from the water pipe that goes out to the zone would be very difficult. So thankfully, very thankfully, you just have to unscrew the top. So that's the next thing I'm going to do here. Let's see what happens. Here it goes. Comes right off. And there's a spring underneath there you got to be careful about. I'm just doing it by hand. Okay, it's a little dirty. And let's take that off. There we go. And so that's the valve housing. There's a little pin there. And here is the diaphragm. And what we have to do is take that off. There's the spring. We want to be very careful about the spring. I'm going to put that on the side. And this is apparently what's gone bad. And there you go. You can see there's a little bit of a split there. I don't know where else, but it doesn't take much in the way of a compromise to cause a problem. Okay, so now we kind of have an idea of what our problem is. And what I want to do is I want to keep dirty water from flowing back into that thing. So I'm just going to plug this up real quick. And I'm going to put the just going to put this back together real quick here, just to keep the water from, let me even put the solenoid in. Okay, so what I did before, because the water came out, was I just had a cup of water and I bailed that area out. This way it stays dry. So I'm gonna have to do that again. But for now, I'm gonna head out to the hardware store and I'm gonna look for a replacement for this guy. There you can see the little opening right there. That's where it's compromised. So, and it doesn't take much because water pressure can do a lot. It'll just go right through there. So basically, I'm going to head off to Home Depot and see if I can find the replacement diaphragm, and then we'll be back and we'll put it back together. Okay, so at Lowe's they didn't have the part I was looking for. But what they did have is another jar top sprinkler valve, and I removed it from this box and matched up the diaphragm to the one that I have now, and it's not an exact match in one part. So if you look at here it is. Like this black piece is not an exact match. It doesn't have this little nipple on it. But other than that, it's a pretty darn like this piece here actually fits perfectly in there. So I'm thinking they didn't have the individual parts, but they had the entire jar top, and this was $11. So I'm gonna go ahead and bring this guy home and take the parts out and try to replace this part with the one that's in here, and we'll see what happens. Okay, so let's go ahead and just kind of work through the basics here of this other valve. So here's the solenoid, and now you can see really up close how these things work. This one doesn't have that hand valve, but I'm just going to unscrew the solenoid. Now this one's made by Orbit, so it's not the Erythritol, but it's got the same basic, it's a jar configuration. You take this off, and now we can see how the whole thing works, right? There's the diaphragm. Here's the spring. There's a little pin that goes through that hole. There's the pin in there, and this all fits together very nicely like that. And there, you can see in there the components of the valve. And then in this case, you can see this particular solenoid comes all the way out, right? So that's kind of interesting, and you can see it's spring loaded. So it's a slightly different one. And what I did was, whoops, and move the tripod a little bit. What I did was I said, all right, let's take this one apart, set it aside for a second. Let's take the diaphragm out of this and then see how it fits in this new guy right here. I mean, in the old top, and it fits pretty well, right? So now I'm just gonna put it back together. I'm gonna push that in. I'm gonna put it back together just like this, and we'll see what happens. So let's go down here and do that. So there's the pin. You can see the pin. I don't know if you can see it, but it's down there, and what we're going to do is this spring goes right there. Get some dirt away from here. That dirt in the water. And then just goes just like that. And we're gonna hold it down. And tighten that guy just like that. Okay. And this guy on top, get that tight down, that thing that had the ridges on it, that gets tightened all the way. And put the ring back on here. Now you tighten this thing down all the way. It just has to be thumb tight. You don't want to go too hard on it because you don't want to strip anything. And then remember earlier I mentioned, let's see if I can clean it off using this water here. I mentioned earlier, you can see that it says on off. I hope you can see that. There we go, on off. And so when it's in the off position, which is fully clockwise, then the only thing that will open the valve is the solenoid. When it's in the on position, which is fully counterclockwise, it essentially is operating the valve by hand. That's why you want this thing, this top piece that fits into the threads there, you want that guy to be tightened all the way because that'll be closed. And then what you do is there's a little kind of protrusion here. So what you do is you put the off position as close to that as you possibly can, like that, because that's the stopping point for turning it off. Then you just turn it that way, and then to turn it on, you just take one 360-degree revolution, and it'll hit that on the other side. So now, let's take the solenoid and let's put it back in. And like I said, we're going to have to clean this wiring up because it's a mess. It's like a rat's nest right now. Okay, so everything's tight. I think everything's pretty tight. And the test will be what happens when I put the hand valve on, which is it's going to lean my tripod right there, right? So let's go ahead. The question is if I put that hand valve on, will water come out of down there around the valve housing, or will the sprinkler just continue to work? That zone will continue to flow. So here comes the big test. And that sprinkler is flowing. So we're going to go to plan B. Now let's just double check this. Yeah, we don't have anything there. So that's not doing the trick. Nothing's leaking here, but that's not doing the trick. I can hear the sprinkler running. I don't know if you can hear it. So we're going to turn that off. And plan B, here's the good news is let's try it one more time. Yep. Okay. All right, plan B. So let's take this off. Plan B. There is a plan B, believe it or not. So we're going to take this off. Hold on a second. Because that's going to fill up with water. What we're going to do is we're actually going to use this part here with... We're going to use this part right here with the other parts. Swap that out. So let's go ahead and we're going to move pretty quickly because this thing's going to fill up with water and I don't want dirt getting in there. Okay. So now let's use, we're going to use this solenoid with this top. The spring's a little tricky. Now we're getting dirt, which we really don't want to get. Okay. And we're going to use this solenoid. So let's see what happens. And we got to get this on top of that. Should have brought my cup. Now let's tighten the solenoid down. And there's a mosquito that wants a piece of me. So he's done. And the sprinkler is still going. And it's not going. That's it. The pressure it pressurized in a way that I think just closed the diaphragm, and I don't see anything happening from the sprinkler. I don't hear it. Let's give it a look. And I don't see it either. So now that lock ring, this ring thing here with the other piece, where is it? With this piece here that opens it up. You know, you can also just do it by opening this. So here, let's see what happens when we... Well, thought maybe that would turn the sprinkler on by hand. I never use that feature anyway, so not a big deal. All right, so that problem, we're fixed. So apparently I can't use the other diaphragm, the new diaphragm from the orbit part, with this particular top from the Erytrol part. But the good news is that the fitting was so close and that it fits we just replaced that in there. Plus we're using the other solenoid. So and who knows, maybe it was a combination of the two things. Maybe the solenoid was problematic as well. So now the sprinkler system seems to be operational, and the next step is to clean up the wires and then wire up this solenoid into the whole system. So one of these leads here is going to go to the green wire, which, remember, if you go back to the wiring panel, green was zone 2, and the other one just goes to common, which is the white, which is what all the other solenoids have one of their leads wired to. And then we'll put the wire nuts back on, and then we'll run through the system to make sure that that it's functioning properly. Now, the one other thing I want to do is I looked at the video I made earlier, and I noticed that the light was so bright on the reflecting off of the voltmeter that you couldn't see the fact that there was 27 volts on it. You could barely see it. So real quickly, I'm going to go activate zone 2 and show you that, so that we can so I can demonstrate to you that piece is actually working. So I'll be right back. Okay, we have the voltmeter connected again, and again the positive lead is connected to the green wire, which is energized right now with whatever voltage is necessary, because I've got the zone manually turned on at the sprinkler control panel. So as you can see here, let's kind of get that into frame. There we go. And hopefully you can see I'm gonna touch the common lead to the white wire. And there you go. You can see it's about what, 26.9 and change, 27 volts. These home circuits, the 24 volt circuits, are never exact, but there you go. That's that. So now that problem's solved, actually before I clean up the wiring, what I'm going to do is I'm going to double check and make sure that that when I activate this solenoid, it opens up those sprinklers. And so I'm going to take this twisty tie off here. There we go. And take these ends off. Here's another mosquito wanting a piece of me, and I'm gonna get him before he gets me. All right. So I'm just gonna go ahead and wrap one of these around this guy here, the common. And now, theoretically, if I touch these two, the sprinkler will turn on. So let's see what happens. You may not be able to hear it through the microphone, but I certainly can hear it because I'm not too far from it. And there it goes. And then if I take it off, let's try this one more time. Well, it's interesting because I still hear the sprinkler running. So this is an interesting test here. Why would that be running? So let's turn the hand valve off. Let's try it one more time. So now the question is why is that not shutting off? Okay, so I'm going to show you what I meant by bailing it out. There we go. A bit of time-consuming process. I could probably use a siphon. I even have one of those somewhere, but I'm not going to bother. It's relatively quickly here. But the reason I'm doing this is because in an attempt to diagnose the problem, I'm going to pull this apart one more time. And the water from that zone is going to definitely drain, just start to drain out here. And I don't want it to overflow in a way that gets a bunch of dirt and stuff in there. So I'm going to get this water out, and then when I am done getting this out, I'll unscrew the solenoid, and I'll let it drain. Now I could unscrew the whole top, but it'll drain a lot faster if I do that. The whole top to the jar top valve, and I'm going to be bailing as the system drains, because there's water in the system, you know, going out to the sprinkler heads, and that the system is higher in, you know, elevation wise than the valve. That's how these systems operate. And so I have to that's why the water basically goes downhill and will come out the valve. So I want to make sure that I have all this water out of here, as much of it as possible, so that the dirty water doesn't fill the valve, fill the sprinkler valve. So let's go ahead and take first. Well, here, I can leave that plugged on there for now. Unscrew this guy here. Blow to my leg. Okay, now it's starting to drain, but slowly, because it's just coming through a little pinhole. And while I'm doing this, I'm going to take this guy, and I have zone 2 activated. So that seems to be working, right? So you can see, I don't know if you can see that, but when I activate it, there it goes, it pulls it in, right? So the question is why is the zone not shutting off? And that was working perfectly. Alright, well, let's take this off for now. This solenoid. Move it over here. And while this is, we're going to let this drain, and I'm going to bail it out, and then I'll come back to you. Okay, so I believe I discovered the problem. I put the spring on the wrong side. I put the spring inside the housing first, and then put this on top of there, and of course it was forcing it open. The spring goes on this side, and then this goes over that like that, and that's where I made my mistake. Total rookie mistake. And so one of the things is that I noticed was, if you see, See, here's the old spring, right? And here's the old top. And then here's the old valve, and you can see that here's the old valve diaphragm, and you can see how the spring fits perfectly around that fitting. And then it fits perfectly there, like that, and then those two things come together like that. So if I'm going to use the new spring, or if I'm going to use the new diaphragm, I need a spring that fits the diaphragm. So this spring from the old one doesn't exactly fit in there, it kind of moves around, but the big spring fits perfectly. Bingo. Right, so now I'm going to take this top, there we go. Now I'm going to put that back together like that. Okay, and now I got to put it back on. So let's try this one more time. I'm going to put that over the pin. I want it to fit nice and snug. Let's get it over the pin. There we go. Let's hold that down. Bingo. Okay. And then let's go ahead and put this guy back on. And let's see what happens if we turn the water on. Whoa, you heard that shut pretty quickly. And that shut perfectly. So now let's try. I have the second zone energized, so let's go ahead and see what happens. There it goes, just turned on. Now let's turn it off. Turned off. Aha! We are back in business, and it's working beautifully. Now, theoretically, you can just loosen this guy up and it'll turn the zone on too, so let's see what happens. Now, the next thing I'm going to do, because it seems to be working pretty well, is I'm going to go ahead and button it up. And what I mean by that is I'm going to clean up the wiring. Here's the old solenoid. I'm going to get rid of that, or take it out, and clean up the wiring so it's nice and neat for all the zones. And we'll come back to you when I have all of that done, and of course wire up the new solenoid. So let me work on that and I'll show it to you, and then we'll see if the sprinklers are working as they should be. Okay, I know it doesn't look very neat, but it actually is. Now, of course, when you're doing like guitar amps, what you do is you bundle wires together, use things like zip ties and stuff. But the reason we can't do it with these guys is because at some point, if you have to maintain it, you basically would have to undo that anyway. And the reason that is because if you're unscrewing a solenoid, it's essentially twisting the wires like that, and the wires need to have a little bit of play in them, a little bit of slack in order to accomplish that. But what I did was, this is the white lead, I kind of sent it off in this direction, and all of the ground leads going to it are like on this side of the box. And then all of the hot leads over here essentially are on this side of the box, and they're not tangled with each other. So here's zone 2 going to green, here's zone 3 going to yellow, zone 4 to blue off on this side. None of the wires are tangled with each other, so theoretically we're ready to go. So the real test to see if it just hangs on is if I turn the hand valve on. So let's give that a shot. And that's it. The whole system's pressurized. Nothing's leaking. And the only test that's left, which is to actually run through the different sprinkler zones. And I can't do that with you here because there's no way for me to kind of keep the camera going and talk you through it because the control box is downstairs. But what I can do is I can go downstairs and we might be able to hear the system switching from one to the other in a way that clearly indicates that one zone is shutting off and the other zone is activating. So what I'm going to do is we'll go down there and we'll just give it a shot. Okay, the handle, the hand valve that feeds the entire system is on. So let's head down to the control, the sprinkler control in the basement, and give it a manual whirl. All right, here we are at the control panel, and as you can see, it's showing the time of day. So it's off. When it's on, it's not showing the time of day, it's showing how many minutes are left. And so what I'm going to do with my dirty fingers is start zone 1. And if you can hear it, I don't know if the microphone will pick it up, but it's going to make, you're going to hear water flowing. I can hear it from here, so let's give it a shot. Okay, water is flowing. And that's zone 1. Zone 1 was not problematic. Now we're going to advance to the problematic zone. Zone, as you can see, it says zone 1 there. Let's go to zone 2. Okay. I just heard zone 2 kick on. Now let's go to zone 3. I heard zone 3 kick on. And then let's go to zone 4. I don't know if you heard that. It's like a squeak. Okay. Zone 4 is running. And so now the big question is, actually I'm going to go back to zone 1. So I'm going to turn off. Let's go to zone 1, let that go. And let's now go see if zone 2 is solid and not on. The only zone that should be on is zone 1. So let's go check that out. Okay, we're in my backyard, and like I said, we have 4 zones. They're organized basically into corners of the property. We have a pretty small property, and this is zone 1. You can see the sprinklers going here. There's a sprinkler way off there in the trees. We've got to clip those back a little bit. And here's a sprinkler over here. Okay? But zone 2 is this corner of the property. And if we go over here, everything's quiet. No sprinklers going. How about them apples? So there you have it. We dissected the sprinkler valve, replaced its diaphragm, replaced the solenoid, replaced the top, just because the other diaphragm only fit the top of the new valve. And thankfully, some of those parts fit together from Irritrol and Orbit in a way that I was able to make it all work. But this zone is nice and quiet, and what that means is that it won't run continuously in a way that wastes a ton of water. Never mind the fact that where I live, you have to pay for your water. So that's it. The
Typically, the sprinkler guy would probably charge somewhere around $300 or $400 for that repair. Total cost to me, not including my time, of course, $11 for the part. How about them apples? I think I said that already, but I mean, that's really what it comes down to. You know, being able to take those skills that I've honed fixing amps, double check the electricity, and going to the valves, the sprinkler valves, the 24-volt lines, making sure that that all works, making sure that the sprinkler control is functioning as it should be, and then narrowing down the problem through the process of deduction, one step at a time from there. So it all worked out. Thanks very much for watching. If you have questions or comments, feel free to put them down below. And just one other little disclaimer, just because it's 24 volts doesn't mean you can't get a shock, especially when you're dealing with water. So be sure to be super careful when working with electricity. All right, good luck. Talk to you soon.